Day 26, Honors Physics, Problem 36. Here's your basic diagram and setup. This ball or stone is tossed with an initial upward speed from the ground of 18, that's positive 18 meters per second. It's going to go up and pass the 12-meter mark on the way up, and then pass the 12-meter mark on its way down. So it's going to pass that location twice. So we'll get two answers you'll see as this plays out. If we take A as negative 9.8 meters per second squared, like you do in all gravity problems, and we're looking for 12 meters. Okay. Once again, there's probably different ways of doing this problem, but I think the most direct, and usually the shorter way is the better way, but let's see what happens here. If I use the equation S equals V sub, this is the third equation, V sub I times T plus 1/2 AT squared, and I try to avoid this equation because sometimes it results in quadratics, which I think is the case this time, but it might be the fastest way to do this problem. In other words, if I just plug in here, though, I have 12 equals 18t plus 1/2 times negative 9.8 t squared. If you move things around algebraically, well, 1/2 of the 9.8 is 4.9, and move that over. Bottom line is you get in the quadratic, standard quadratic form, 4.9. I'm moving the negative 9 point, or the t squared factor term over to the left-hand side. Everything over to the left-hand side. All right, I've simplified that. That's in standard quadratic form, and just use the quadratic equation. In other words, to solve for t, you will have t equals the opposite of b, which would be 18, plus or minus the square root of b squared, which is 18 squared, or negative 18 squared, minus 4 times a, which is 4.9, times c, which is 12, all over 2 times a, 2 times 4.9. So this will give you, as you can see, 2 times. It'll give you a t sub 1, which will be the time on the way up as it passes the 12-meter mark, and t sub 2. Well, once you have the 2 times, then you'll need to find v sub f, or the velocity at the time it passes that mark on the way up and on the way down. So I believe you can just use you can use the other equations, but I think either one or any of the equations will work, but the one v sub f equals v sub I plus at, you'll use that twice to get your v final that matches up with your t sub 1 and your t sub 2. And I think you'll find that v sub f on the way down will be the same numerical value as v sub f on the way up, but one will be negative. The one that matches up with t sub 2 will be negative because the ball will be traveling downward, or the rock will be traveling downward on that last leg of this journey.